let's see if I can move me over there. Yeah, see, now I move. So we have been dealing with powers, right? We're into the lesson now. We're about to start the lesson. We have been talking recently about powers, right? We've talked about exponents and raising things to powers. And now we're going to be talking about specifically powers of 10. So if we remember, like 10 squared would be 10 times 10, or any number, like, right? We go, if I had 3 to the 4th power, it would be 3 times 3 times 3 times 3, right? So that's what that power means. So here, if I have 10 to the 5th, I have 10. There's a fly on my screen right now. Times 10 times 10 times 10 times 10, right? In its expanded form, that's what it would look like. And that 10 times 10 times 10 times 10 times 10 has a value of, sorry, I can't find where I put my desk is a mess right now because I was late for work this morning. I mean, I wasn't actually late for work, but I was kind of late for work. So basically, what this gives me is a 1 with 1, 2, 3, 4, 5 zeros, right? So this value would be 100,000. Here, 10 to the 4th, I have 10 times 10 times 10 times 10, right? I would have 1 and 1, 2, 3, 4 zeros. Yeah, 10,000, right? Whatever I have here, if I have 10 to the 3rd power, I have 10 times 10 times 10. How many zeros am I going to have? I'm going to have 1 and 3 zeros. Pretty easy, right? 10 squared, 10 times 10, 100. 10 times 1, well, that's just 10. 10 to the 0 power, well, that's just 1. Yeah. Anything, little trick, anything raised to the 0 power is 1. It doesn't matter what number it is. I could have 14 raised to the 0 power, it's going to equal 1. It's a good thing to learn. People will forget it. And as you get into math, and math gets harder and harder and harder, right? Sometimes they'll trick you. They'll give you all sorts of math, and then at the end of the brackets, they'll just raise it to the 0 power. And so this whole crazy complex equation just equals 1 because at the end they raised it to the 0 power. And if you're not paying attention, you'll do all that work on the inside and then get to the end and realize it's raised to the 0 power, and you could have just written 1. So this is a special, huh? Well, for this so far, I mean, we're going to play with it a little bit too, because this is whole numbers, but sometimes we have what we call fractional form, right? And that's what happens when we're raising it to a negative power. Because remember, I was talking about how it can get really, really big and really, really small, and that's what the kind of numbers we're dealing with. Either really, really big numbers, which if we look at these, right, we go from 1 all the way up to 100,000. If this was 10 to the 6th, it would be a million. If it was 10 to the 7th, it'd be 10 million. If it was 10 to the 8th, it would be 100 million, right? Then we'd be in the billions, and we'd be work our way up to the trillions. And these numbers can get big really, 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 really fast, right? But they can also get small really, really, really fast in that same respect, right? So if um, I will, I can't do anything about that. Hopefully, it's recording well. That's all I can hope for, right? If I have a negative power, if I have 10 to the negative n, that can be written as 1 over 10 to the n power, right? N is just some number, right? Whatever number. What? What? Well, the number that's on the worksheet is n, so no, I have to use, because it's not a variable in the same sense. It's just some number n. Would it work for an x? Yes, but powers, for some reason, they always use n. So in this case, I have 10 to the negative 1, right? That would be written as 1 over 10 to the 1 power, which is just 1 over 10. It becomes positive. Notice, see how it's 10 to the negative n right here? And when it's just a fractional rule, right? When we have a power, there's a lot of rules that it can explain it, but they are super complex. So you might just have to take my word on this one until we get into Algebra 2 when I explain it to you. Yes, Leah? It's always going to be over 1 unless, for you guys at this point, it'll always be over 1. If it's raised to a negative fraction, then there would be a different number over it, but we're not going to deal with anything like that in this class. So if I have anything raised to a power at this point, we will write it over under 1. Yes, Jason? Oh, they want it in decimal form? Thank you. So let me erase that. In fractional form, it's to the 1, right? So we've got 0.1. You could write it as 0.10, but we really don't do that, right? So what you want to think about is, okay, I have a number 1, right? Like we're basically kind of running things off 1. Well, let's do the next few so you can kind of see the pattern, and then we'll talk about the pattern. So this becomes 1 over 10 squared, right? We have 10 to the negative 2, and we'll just write it over 1 over 10 to the 2 power. So here I've got 0.01. We're going backwards now with our decimals. If I have 1 over 10 to the 3 power, right, because that's to the negative 3, I have 0.001. If I have 10 to the 4th, I've got 1 over 10 to the 4th power, and I'm going to have 0.0001. 10 to the 5th, negative 5. Well, this is the 10th, right? The top one is the 10th. Then this is the 100th, the 1,000th, the 10,000th, and now we are going into the 100,000th place. So 10 to the 5th. No, that would be the million, right? So technically, yes, we just don't call it the thousandth, right? We call it the millionth. But this is what I mean about things getting astronomically small really, really fast, right? Because now we've got 0.00001, right? That's really, really tiny. And we can go tinier and tinier and tinier, right? Based on whether or not, because when we have a fraction, that bigger that bottom number is, the smaller our fraction is, right? Well, that's why we have scientific notation so that we don't have to write it out in that decimal form. We can write it out in that 10 to the negative, I think that would be 99 or something like that, right? For that many zeros. So we're going to talk a little about scientific notation. Scientific notation is a compact way, we're going to call that compact, right? We're compressing these numbers of writing very, very large or very, very small numbers and the power of 10. And the reason we call it scientific notation is because more often than not, the times we're dealing with things that infinitely small, or I should say exponentially small or exponentially large, is when we're talking about science, right? Like bacteria growth or population growth or um, um, half-life of molecules and things like that when they start to disappear. Because in science, when we're talking about these whole pictures, the numbers can get really, really big, and we can't write out all those zeros all the time, right? Like, could you imagine if we had something to the 100th power and we had to write out those zeros every single time, right? So this is a more compact way of doing it. Now, when we're dealing with writing things in scientific notation, we're not always dealing with just the tens, but we break down the tens as much as we can, right? So when we're writing a number from scientific form to standard form, if you look at the numbers that we have here, it says a number written in scientific notation as a form A, which is some number, times 10 to some power, right? But our A has to be between 1 and 10, right? Can't be less than 1. If we look at that first problem, we've got this problem that's written in actual scientific notation, right? Which we have 4.3 times 10 to the 2 power. When I want to write that, I'm just going to move the number of decimal places, right, on this number that I have here. So I'm going to take this decimal and I'm going to move it 1, 2 spaces, right? So if I have 4.3 and I need to move this decimal over 1, 2 spaces, I wind up with 430. It just tells me how many places to move that decimal. If there's nothing past that decimal, I have to write it in, right? So here I have 2.19, right? And I need to move that decimal in this direction 7 spaces. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Hold on until I'm finished, okay? 1, 2, 3, 4, 5. Why 7? Because it's raised to the 7th power. We're we're moving it to whatever that power is. So here, my new number is going to be 2, 1, 9, 0, 0, 0, 0. How many do I have? 6 zeros? 2, 3, 4, 5, 6. And this is going to give me 219 million. Did you see how fast that got big? Right? We have 2.19, but it's really 219 million. Now imagine if that was to the 25th power. Wouldn't it be a pain to have to write out all those zeros every time? So if we go down to this next problem, number 3, there is no decimal there. But because there is no decimal, it just means that the decimal is right here. It starts after it. And so this would be, we're going to move this decimal over 1, 2, 3, 4 places, and that's where it would be. So we would fill that in with zeros, and we would have 50,000. I thought I saw a hand. Did someone have their hand up? They took it away if they did have their hand up. $7.2. Well, look at this one. This one is to the -1. What do you think I'm going to do with that? Yeah, Daniel? Yeah, we're just going to move it in the opposite direction, right? We're going to start here at this decimal, and instead we're going to move it 1 in that direction, which would give us 72. I'm sorry, 0.72. Can't forget to put the decimal there. Here I have 3 to the -6. I don't have a decimal on here at all right now, right? So technically my decimal would be right here, right? It would come after it because anything smaller would come after it. But we need to move it 1, 2, 3, 4, 5, 6 spaces in that direction. And each one of those gets a 0. So we've got 0.0000003. I know, right? It's a lot of zeros. Yes, Caitlin? Exactly. That's exactly right. It is. I told you this wasn't a hard lesson. Once you understand it, it looks really complicated, right? When you look at these problems, it looks like, oh, these look like they might be hard. But really, it's not that bad. Yes, Gabriel? The negatives go left and the positives go right. So it's all depending on this number right here, right? If this number is negative, you're going to go left. And if this number's positive, you're going to go right. And really it's just a matter of knowing where your decimal starts then. Like here I have 10 to the -3. So that means I'm going to move this decimal that I have 1, 2, 3 spaces over. And I'm going to have 0.00852. Here we're talking about making it going from standard form to scientific notation, which means we're going in the other direction. And so we're going to be moving these. So if we move if the decimal was moved left, the exponent is positive in this case. And if it was moved right, it is negative, right? So if we have something written in this standard form, at the end right here, like if I don't have a decimal, I'm going to put a decimal in, right? And I'm going to move it until I just get right to the number there. So I'm going to go 1, 2, 3, 4, 5. And I am going to get 9 times 10 to the -5. I'm sorry, to the 5. I broke my own rule. I just broke my own rule, right? Because the last time we were doing in the other direction, it would have been negative, but because it's in this direction, it's a positive. I just count, right? Let's look at this one. Well, you'll see. You'll see. So here I don't have a decimal in 2400, right? This one does not have a decimal in it, which means the decimal is going to start right here. And I'm going to move it to 1, 2, 3 spaces, right? Well, because that's what we're doing. And we're going to have 2.4 times 10. How many spaces did I move it? To the third power. Why did I move it 3 spaces? Because our first number has to be between 1 and 10. Exactly. So if I look at this one right here, I don't have a decimal in the next number, right? In number 9, I don't have a decimal here. So I'm going to put my decimal in, and I'm going to have to move it 1, 2, 3, 4, 5, 6, 7, 8. So my first number would be 1. And I moved that 8 spaces. So I have 1.65 times 10 to the 8 power, because I moved it 8 spaces. I think you're right. I think you're right. Again, we've got to move this now in the other direction. We have a decimal. We're going to move it 1, 2, so that our first number is 4, and that is going to be 4 times 10 to the negative 2. I moved it 2 spaces. I think you're right. Let's look at this one. Here we've got a decimal here. We're going to move it 1, 2, 3, 4, 5, 6, 7 spaces. So we have 6.8 times 10 to the negative 7, right? Because we moved it in the other direction. So this time it's going to be negative. Not super hard, right? Here, 1, 2, 3, 4, right? Because this is going to leave me with a 5 if I move the decimal to here. So I've got 5.51 times 10 to the negative, what was it? 1, 2, 3, 4 spaces to the negative 4. That's an ugly 4. It kind of looks like a 9. I feel the need to change it. So not too bad, right? This stuff isn't too bad. I think you guys can handle it. Yes, Leia. Because we're going just till we get a number that's between 1 and 10. What do you mean? I have a 5 and a 1. I have 5.51, right? Because that's what the number is. I can't just toss out the other numbers that are there. I'm just moving it till I get to a number that works. In the same respect that I put it between 6 and 8, right? Once I have that one number, I have to stop with the decimal, because otherwise, if I move it again, it's going to be 68, and that number would be bigger than 1 through 10. Yes, Jason? Yes, because these take seconds. This is not a lot of work, right? You're not showing any work, really. You're just writing out solutions. This one is just saying, well, what's bigger? Or are they equal? You know what? I'm not even going to have you guys do this part. I'll take it off the worksheet too. Okay? I'll change the problems that you guys have to do. That's the whole thing though, right? It's just moving decimals, right? All you have to do is count from which one. Use this worksheet, use your note sheet to kind of understand how to do it. If you get confused, if you go to do your worksheet and all of a sudden you're like, oh, I forgot what we did, use the worksheet and see how we're counting the decimals out, okay? You don't have, the only part you don't have to do is the comparing values part. Yes. No. Yeah, the worksheet. No, you don't. I'm going to go in and change what numbers you have to do in your assignment. Um, I'm going to actually edit it so that you guys only have to do. I'm looking at what's on the worksheet right now. I'm waiting for it to pop up. It's taking its time. Sure. So you guys just do 1 through 20 on your worksheet, okay? So I'm going to go in and change that. I'm going to edit that assignment to be to do numbers 1 through 20. Do numbers 1. I don't know. I'm going to stop this video though.